Berlin, 1943. An officer sits at a mahogany desk, flipping through a German intelligence brief. He raises an eyebrow at the audacious claim. Ford has constructed an aircraft factory so vast it commands its own weather. Every 63 minutes, he scoffs, a bomber rolls off the line. Cars, perhaps. Bombers, impossible. Cut to Willow Run, Michigan. Factory doors creak open, revealing a B-24 Liberator stretching into the daylight, another fuselage gliding overhead. The roar of engines fills the air, a stark contrast to the officer's disbelief. Amidst the hum of assembly lines, a voiceover encapsulates the irony. What Axis planners dismissed as mere propaganda was actually the dawn of America's aerial industrialization. Every bomber produced echoes the resilience and innovation of a nation, determined to defy the impossible. Early in World War II, the challenge facing aircraft manufacturers was monumental. They had to transition from painstakingly handcrafted bombers with thousands of parts that required meticulous assembly to meet the demands of an air war that prized volume and reliability. These early heavy bombers were, in many ways, artisan projects, each one a unique creation with low throughput and inconsistent tolerances. Pilots relied on these machines, but the reality was, when you needed to send hundreds of bombers into the sky, this approach just wouldn't cut it. Consider the B-24 Liberator. It boasted a tremendous range and a hefty payload, making it one of the most promising bombers of its time. However, its intricate design presented serious production challenges. The issue became clear. Could an automobile company, known for its production line efficiency, transform the complex design of a four-engine aircraft into something that rolled out like a Model T? The question loomed. Could they maintain airworthiness without sacrificing the innovative features that made the B-24 so revolutionary? As the air war raged on, the need for speed and reliability became increasingly urgent. The stakes were high. Success or failure could mean the difference between victory and defeat in the skies. In the hushed hours of a Detroit night, when most are asleep, one man stands alone amidst the cacophony of machines and the faint hum of a factory coming to life. Charles Cast Iron Charlie Sorensen, the visionary behind the Willow Run bomber plant, sketches an ambitious plan across the concrete floor. By the soft glow of overhead lights, he carefully outlines the intricate choreography of what will become the heart of America's war effort, the assembly line for the B-24 Liberator bomber. At this late hour, the air is thick with anticipation. The vision Sorensen envisions transforms every element of production, turning a labor-intensive process into a seamless, innovative ballet. His draft isn't just a sketch, it's a philosophy. Sorensen believes that the way to beat the clock isn't just by working longer, but by working smarter. His mantra, bring the parts to the workers, rather than the other way around. This simple yet revolutionary approach acknowledges the inherent value of human labor, ensuring workers aren't shuffled around inefficiently, but are perfectly positioned to contribute where they're needed most. Imagine the factory floor, a mile of structured efficiency, each section designed to optimize takt time, the heartbeat of production. As he plots the layout, rail spurs snake beneath the building, ready to transport vital components straight to the assembly lines. Nearby, a lined runway awaits, poised to cradle the aircraft that will emerge from this metal-clad behemoth, ready to take to the skies and serve the nation. As Sorensen continues to draft and refine these ideas in the dead of night, a profound sense of purpose drives him. This is no ordinary factory. It will become Willow Run, a sprawling temple dedicated to innovation and speed, where the raw materials of war will be transformed into flying fortresses. In this place, every rivet, every wing, and every engine will symbolize the might of American ingenuity, forever changing the landscape of aviation and the outcome of the war. Through his eyes, we see a transformative moment in history, one where the factory is not just a place of labor, but a machine in itself, pulsating with energy and intent. As he stands back, surveying his chalk lines, he's not just imagining a new assembly line. He's thus laying the groundwork for a legacy that will echo through the ages, a convergence of American spirit, innovation, and sheer determination. As Ford took on the monumental task of re-engineering the Liberator, the challenge was to transform the chaos of artisan craftsmanship into a streamlined, efficient production process. This wasn't just about copying the methods that Consolidated had used, it meant reimagining how parts would intersect in a way that embraced consistency and quality at an unprecedented scale. Imagine stepping into a workshop where every component is meticulously planned, each piece ready to fit snugly into its place like the final piece of a puzzle. Ford knew that to achieve this, traditional craftsmanship had to evolve. They introduced a system of jigs, fixtures, and precision gauges, which allowed for a level of repeatability that artisans could only dream of. Where once a craftsman might rely on his unique touch, now machines would guide the way, ensuring that every connection, every fit, met a strict standard. The production line became a symphony of efficiency as rivet patterns were rationalized. This wasn't just a matter of making it easier to assemble, it was all about creating a framework that fit together like clockwork. The approach also extended to how wiring looms were designed, pre-cut and tailored to each section of the plane. With hydraulics that were pre-bent, Ford envisioned a seamless integration where functionality met innovation. And let's not forget the interiors. By utilizing kits, every factor was accounted for, every piece linked together with precision. This organization meant that workers on the assembly line didn't scramble to find parts. They had everything they needed right at their fingertips. Transitioning from a chaotic array of components to a neatly orchestrated assembly was crucial, not just for efficiency, but also for morale on the line. The innovation didn't stop there. Ford adopted a parallel production strategy for sub-assemblies, constructing wing sections, tail cones, and nose modules in tandem. This ensured that when it came time to marry the various sections of the aircraft, everything fell into place as if they were meant to be together. The ultimate goal, it was interchangeability. The idea that any piece could fit seamlessly into any airframe meant that Ford could scale production without compromising quality. This dynamic approach not only allowed for rapid changes in manufacturing, but also established a level of trust in the product. It was about creating an aircraft that worked time after time without fail. In this way, the Liberator was more than just a machine. It reflected a revolutionary change in how we think about manufacturing, bringing together precision engineering, efficiency, and a touch of artistry. Ford wasn't just building planes, they were setting a new standard for the entire industry. Amidst the backdrop of a nation at war, a remarkable transformation unfolded, powered by the spirit and determination of everyday people. Tens of thousands flocked to factories, many leaving their homes behind in search of opportunity. They were farmhands and auto workers, but their identities quickly evolved. Among them were the iconic Rosies, women who rolled up their sleeves, donned blue collars, and took on the challenges of building planes, ships, and weapons. They became symbols of resilience and empowerment, embodying the notion that everyone had a part to play in the war effort. As these diverse groups of individuals converged on factories like Ford, a new way of life was being forged. This was not just about labor, it was about community. Within the towering walls of these industrial giants, classrooms sprang to life, integrating education with production. Workers learned drill press basics, rivet quality, and the fine art of sheet metal shaping. Safety protocols weren't just rules, they were a lifeline. The drive to maintain high standards ignited a culture of quality policing. Inspectors, armed with go-no-go gauges and stamp hammers, meticulously roamed the production lines, stopping defects before they could tarnish the effort being poured into each piece. Outside the factory doors, the growth was just as significant. Cafeterias filled with laughter and camaraderie, buses shuttled workers to their posts, and entire neighborhoods sprang up to support this burgeoning workforce. This wasn't merely a relocation of labor, it was the establishment of a new identity, a collective narrative born from grit and ambition. Every rivet-driven and sheet metal shaped became a testament to the power of unity and purpose, illustrating how ordinary lives can intersect to create extraordinary change. In this environment, each individual's contribution was vital, woven into the larger fabric of a nation rallying together in the face of adversity. Imagine stepping inside a bustling aircraft manufacturing facility where the air hums with the energy of teamwork and precision. The entire structure operates like a well-oiled machine, and at its heart is an incredible supply chain designed to ensure that every component arrives exactly where it's needed, right on cue. Let's start with the arrival of materials. Boxcars roll into dedicated bays, unloading essential materials like aluminum, engines, and tires. This is like the lifeblood of the factory. These components are pivotal to the creation of an aircraft. Each delivery is timed perfectly, ensuring that the flow of production never misses a beat. As parts come off the boxcars, they don't just sit idle. They begin their journey through the factory, waiting for their moment to shine. Next, think about the kitting teams. These are the unsung heroes who meticulously gather fasteners and fittings, pre-packaging them so that assembly crews can grab exactly what they need on the fly. No one wants to waste time rummaging through bins looking for a specific bolt. Instead, these kits allow teams to stay focused and maintain momentum, ensuring a seamless workflow that keeps everyone energized. Above, miles of overhead conveyors float gracefully, transporting massive wings and control surfaces. Picture this: thousands of pounds of aluminum gliding effortlessly through the air, suspended on these conveyors, almost as if they're part of a ballet. The precision here is astonishing. These components, which will eventually soar through the sky, glide overhead instead of crowding the floor lines, freeing up space and maintaining a clean workspace for the teams on the ground. In this logistic marvel, supermarkets for sub-assemblies act as crucial buffers against variability. They regulate the flow of production and ensure that when the final assembly line pulses to life, everything hits just right. These supermarkets are stocked with all the essential subcomponents ready to meet demand without delay, smoothing out the busy rhythms of the factory. And when a finished aircraft rolls off the line, it doesn't just stop at the door, it transitions directly to a flight test, then on to modification centers. This quick movement from assembly to testing is a testament to the efficiency of the factory. Each moment is choreographed to keep everything in motion, reducing downtime to an absolute minimum. It's incredible how this entire building functions as a logistics organism, finely tuned to a matter of minutes. Every step, every process is designed not just for speed, but for synergy, showcasing the intricate dance of modern manufacturing. As we dive deeper into the transformation of the B-24 production line, we must confront the stark reality of the early days, a period marked by struggle and frustration. Picture a bustling factory filled with ambition, yet overshadowed by the sobering challenges of reality. Outputs lagged behind expectations, leading to a cascade of morale-sapping days. Workers faced a bitter winter, not just outside but in their spirits, as machines creaked and parts laid idle. B-24s rolled off the line, but far from perfect. Some airplanes emerged overweight as engineers scrambled against the clock to make adjustments. Wing rigs got tangled in the assembly process, parts arrived late, and fingers were crossed that everything would fit together seamlessly. But too often, they didn't. The determination to succeed clashed with the tangible frustrations of misaligned tolerances and poorly coordinated efforts. Yet within that darkness, there sparked a flicker of resolve. Ford's response to this chaos was born from a combination of ingenuity and sheer will. The strategy was straightforward: understand the problems in detail and eliminate them ruthlessly. More gauges were added to monitor variables closely. Tighter fixtures ensured that every component met the stringent specifications needed for safety and performance. The assembly line was dissected through station-by-station time studies, where each task was analyzed down to the second. It was a systematic approach to root out inefficiencies. The focus shifted to tackling bottlenecks one by one. A simple missing jig here, a slow rivet gun there, and an inefficient method for staging the wiring harnesses became the targets of intense scrutiny. Every team contributed their insights, designing improvements to streamline processes, enhance productivity, and reclaim lost time. Slowly, rigorously, they chipped away at the obstacles bit by bit. As the teams implemented these changes, something remarkable began to happen. Throughput climbed and defects plummeted. With every conquered hurdle, the once distant vision of efficiency grew increasingly tangible. What felt like an insurmountable learning curve started to reveal itself as a runway of potential, a path leading toward a future where quality and speed converged, culminating in the production of a legendary aircraft. This was not just an evolution in manufacturing, it was a testament to resilience, teamwork, and the belief that from struggle, greatness can be forged. Tact time, a term that resonates deeply within the realm of manufacturing, especially when excellence is at stake. Think of it as the very heartbeat of customer demand dictating the rhythm of production. In the world of aircraft manufacturing, this takes on a monumental significance as we explore what it means to produce a bomber every 63 minutes at peak capacity. Imagine an assembly line where every team member is in sync, each task perfectly aligned to this aggressive timeline. From the moment the fuselage begins its journey down the line, the first station springs to life. Here, skilled technicians install the landing gear, ensuring that this critical component is secured not just for functionality, but for safety, setting the standard for everything that follows. As the aircraft progresses, the second station seamlessly transitions into action. Engines are hung, which not only lends the aircraft its power, but also requires a meticulous attention to detail. Every bolt tightened to specifications, every surface inspected for imperfections. This stage illustrates a point. Speed does not come at the expense of quality. It's about integrating efficiency with rigor. Next, rigging controls might seem straightforward, yet it demands profound expertise and patience. Each cable and rod needs to operate flawlessly to ensure that the pilot can maneuver the aircraft precisely, especially with the aircraft's wings poised to dominate oceans. It's an impressive dance of mechanics, where one misstep can have consequences far beyond the factory floor. Then we encounter a crucial pause in the rush: the safety and quality gates. Even with the drumbeat of 63 minutes echoing in the background, these checkpoints become the unsung heroes, ensuring that integrity is never compromised. Torque checks let us verify that everything is fastened correctly, while dye-penetrant inspections reveal surface flaws invisible to the naked eye. These practices ensure that the aircraft isn't just a product of speed, but one that can withstand the pressures of flight. As we move to the final stages, testing hydraulics, fueling, and firing systems may seem like a race against the clock, but every action here is laden with purpose. This isn't just about getting the bomber out the door, it's about the knowledge that it will cross vast distances with the utmost reliability. So when we refer to this process as the 63-minute miracle, we're acknowledging a holistic approach, balancing speed with discipline, camaraderie with craftsmanship, creating an aircraft engineered for the skies. The beauty of it lies in how, amidst the urgency, every individual involved knows that their role contributes not just to the pace, but to the formidable mission of building something that, when airborne, embodies their entire effort. As we zoom out from the chaos of individual battles and look at the bigger picture, a remarkable transformation in the air war unfolds. Hundreds of B-24 Liberators streamed into the fray, arriving on the front lines faster than losses could take them out. This wasn't just a numbers game, it was a game changer. Each new squadron bolstered campaigns from the oil fields of Ploiești to the vast Pacific skies, breathing life into strategies that were once riddled with uncertainty. Imagine for a moment the men and women back home in factories, their hands skillfully assembling aircraft, working around the clock. The rhythm of their labor was synchronized not just with the machines, but with the pulse of the war itself. Spare parts were churned out in abundance, and standardized repairs meant that aircraft could be mended and sent back into the sky in record time. No longer did crews face the frustrating unpredictability of varied components. Interchangeable parts brought a new level of trust. They knew that whatever arrived at the hangar would fit seamlessly, allowing pilots to return to the skies with confidence. Mass matters in warfare. With every Liberator joining the ranks, air planners were presented with unprecedented opportunities. More reconnaissance missions, increased strike capabilities, and additional aircraft for pilot training. They weren't scheduling operations based on hope anymore. They had data and availability to guide their strategies. The result? A new kind of certainty in the chaos of war. The factory's clock started to influence the air war's calendar, dictating when and where aircraft would ply the skies. It forged a connection between the industrial might of the home front and the fierce battles being fought far overhead. This synergy not only supported weaker fronts, but also reshaped the very essence of how air power was leveraged, turning the tide in ways that would echo through history. As we delve deeper into the strategies that emerged from this newfound strength, it's crucial to acknowledge just how pivotal those factories were, not just locations of production, but powerful engines of victory. Amidst the tangled web of espionage during World War II, the Axis received alarming reports from their spies that painted a picture of American industrial power unlike anything they could fathom. To these analysts, who were shaped by a deep-rooted tradition of artisan craftsmanship in aircraft manufacturing, the notion that bombers could be mass-produced on an assembly line seemed unfathomable. They envisioned a factory floor bustling with skilled artisans carefully molding and shaping each aircraft, pouring their skill and pride into every rivet and wing. Yet what they encountered instead was a strikingly different reality, a veritable assembly river. This was no artisanal workshop, it was a streamlined operation where fuselages glided effortlessly past workers, akin to automobile chassis rolling off a production line. The sight was bewildering to them. How could such a method produce bombers that would truly take to the skies? This skepticism stemmed from the Axis mindset, steeped in an understanding of aviation that revered the individual craftsman over industrial efficiency. They struggled to accept the mechanics of interchangeability, the very heart of the American manufacturing revolution. While they admired the beauty of handcrafted airplanes, they couldn't comprehend that metrology and the precision of gauges allowed for parts to fit together flawlessly, regardless of when or where they were made. As time passed, that skepticism would fade into a dim echo, but not without a cost. By then, the Allies were producing bombers at a staggering clip, turning out aircraft on a scale that overwhelmed Axis expectations. The volume of these war machines became an undeniable strategic reality, one that no U-boat or sabotage campaign could successfully disrupt. It's this story of underestimation that resonates deeply, showcasing how innovation can sometimes eclipse tradition, leaving even the most seasoned analysts grappling to catch up with a rapidly changing battlefield. The lesson here is clear. Assuming the old methods and practices are the only pathways to success can leave one blind to the disruptive power of new ideas. And in war, as in life, the need for adaptability can dictate the very outcome of the struggle. The story of Willow Run is not just about the assembly line, it's about how innovation can reshape our very understanding of production and efficiency. This factory, once an ambitious response to the demands of World War II, left an indelible mark on industries well beyond its original purpose. As the roar of B-24 Liberators faded into history, the principles honed within those walls were anything but obsolete. Instead, they echoed through the booming post-war economy, becoming the DNA of modern manufacturing. At Willow Run, techniques such as kitting, flow manufacturing, takt time, and modular sub-assemblies were born out of necessity. These methods not only revolutionized aircraft production, but also paved the way for advancements in both aerospace and automotive sectors. Picture this: the very idea that you could streamline production to such an extent that a bomber could roll off the line every 63 minutes was nearly unfathomable. Yet, it's precisely this bold ambition that translated into tangible systems we now take for granted in factories worldwide. As the world transitioned into the jet age and the era of the interstate highway system, the lessons learned from Willow Run were directly applied. Think about it. Those same principles that enabled mass production of military aircraft were key in building high-speed highways and sleek automobiles that define our roads today. The irony here is profound. What began as a response to a war effort morphed into a blueprint for achieving the seemingly impossible, all on a schedule. Ford and his team didn't just make cars or airplanes, they crafted the very concept of time management in manufacturing. As German spies observed, the true power of Ford's innovation lay not only in the products, but in the efficiencies that allowed those products to be delivered faster, allowing society to evolve at an unprecedented rate. In the end, Willow Run represents more than just a factory's output. It illustrates a legacy of how a single audacious idea can reverberate through generations, shaping the future of industries and lives in ways we continue to feel today. It reminds us that in the realm of possibility, sometimes the only limits we face are the ones we impose on ourselves. As the doors roll back, the air thick with anticipation, another B-24 edges into the daylight, a testament to creativity born from necessity. Those early skeptics who laughed at the ambitions behind this marvel now stand in awe as the next airframe glides into its final assembly. It's a striking moment where underestimation meets the relentless spirit of American systems thinking, transforming doubt into triumph. This cycle of turning embarrassment into opportunity is a rich theme we'll explore further. Join us next time, where we'll delve into another chapter of innovation, revealing how the US scaled not just machines, but methods, turning setbacks into advantages. You won't want to miss it.